All right, let's think about this one. Arctangent of x. What is it we know to do with arctangent of x? Do we know its derivative or its antiderivative? And so I claim that we know its derivative. So that's why we should let u equal the arctangent of x. And then what is left to let dv equal, you ask? Well, the rest of this would be dx. So there you go. Okay, so just to map it out, this is my u value, and then this is my dv value. Okay. All right, so then if u is arctangent of x, what would du be? Well, it would be 1 over 1 plus x squared dx. And if v is dx, then what was v? Yep, it was x. There you go. All right, so let's look at this. This would equal u times v, so that would be x times arctangent of x. But because of the bounds that you see on the integral, you'd need to make sure that you kind of indicate that you'll be evaluating this with the bounds, okay, that it's a definite integral. And then minus the integral of v, which was x, and then du. And again, indicating that that integral had bounds. There we go. All right, up to you what you want to do with this first part. There's evaluate it now or evaluate it later. I think I'm going to go ahead and just maybe evaluate it now. So if you plug 1 in, you'd have 1 times the arctangent of 1 minus 0 times the arctangent of 0. And I think I'll come back and finish that out later. The remaining integral, I'm going to write it as the integral from 0 to 1, and I'm just going to put the x on top. There we go. Little pushing it off till later. Little dirtbag math. Never hurt anybody. All right, now looking at the remaining integral, how would we go about that? We'll take stock of the degree of the numerator being 1 and the degree of the denominator being 1 greater or 2. And so hopefully it makes sense that we would try some substitution and substituting something in for the denominator. Now, u has already been used, so I would recommend you use a new letter. It's considered poor form to use u and v to represent more than one thing in the same problem. So I'm going to choose w, and I'm going to let w equal that denominator there. There you go. And then what would dw equal? It would be 2x dx. Okay, so let's continue. I'd have 1 times arctangent of 1. Now keep in mind, this is asking tangent of what angle equals 1, and that angle measure would be what the arctangent of 1 equals. And so hopefully it makes sense. The answer would be pi over 4. So the arctangent of 1 is pi over 4. And then similarly, what would the arctangent of 0 be? It's asking tangent of what angle is 0. And so hopefully 0 makes sense. So I'm just going to go ahead and show evidence of me thinking that out for that second part. Not that it matters. You're going to multiply it by 0 anyway, right? All right, let's see. Now let's talk about this integral in terms of w. So let's see. X dx is worth half of a dw. So I think I'm going to pull the 1/2 out front. Okay. And I kind of don't want to back substitute in terms of x for this one, so I'm just going to change my bounds. So if x was 0, go back to this relationship here. If x is 0, what would w equal? Well, w would equal 1 plus 0 squared, or 1. So I'm going to make my lower bound be 1. If x was 1 for that upper bound, then w would equal 1 plus 1 squared, or w would equal 2. Like so. Okay. All right. So then we'd have natural log of the absolute value of w from 1 to 2. And since 1 and 2 are in terms of w, there's no need for me to put that back in terms of x. So I'd have 1/2 natural log of absolute value of 2 is 2. And then make sure you subtract the lower bound, so I'd actually end up with plus 1/2 times the natural log of 1. All right, and then natural log of 1, remember that's asking e to what power equals 1. The answer is 0, and so one version of the final answer would be just that. There we go. Hopefully you got that in one way or the other, and if you didn't, hopefully it at least makes sense now. All right. Next example. All right, my friends, example 3, integrate x squared times cosine of x with respect to x. See how it goes. Check in with me in the next video. Good luck. By the way, you get a huge pat on the back if you figure this out.